Now this under root x square plus a square dx is equal to x by 2 under root x square plus a square by 2. Then we have a log x plus under root x square plus a square plus a constant of integration. Now from where this formula has come or from where this result has come, we need to prove it. We need to show the examiner or the person that okay, this is how it has come. So let's solve it first and give you the proof. So we have this I, we are calling it as I, and this is equal to under root x square plus a square integration. Now you can write it as a square plus x square and x square plus a square interchangeably because they both are same. So we'll do it by parts. That is, we assume that is one is multiplied here and dx is already there because we are integrating. What is the first function? The first function will take it as under root a square plus x square and the second function will take it as 1. Now when you have two functions and you want to integrate this, we apply a certain formula or as a result u integration of v dx minus integration of differentiation of first function, integration of again the second function, and that differential and integral will be multiplied and then it will be integrated again. So this will come outside because this is the first function a square plus x square. Then we have the integral of what? 1 dx. Then minus integration. Then the differentiation of the first function which is under root a square plus x square. Then after this integration of 1 dx again. That is the one which we are doing for the parts and we assume that 1 is multiplied there. And then again the integration. So this 1 dx will simply give you x. Under root a square plus x square is here. It remains unchanged. Minus. Now integration of what? 1 dx is going to be x only. Let's call it x here only because I am going to replace it. Now d by dx of under root a square plus x square can be done separately because you know d by dx of under root x is 1 by twice under root x. So if you assume this under root a square plus x square as under root x, it will be simply 1 by twice of under root x. So under root a square plus x square I have written. Now you don't have to stop here, you have to differentiate a square plus x square also. Now what is the differentiation of a square plus x square? A square will be 0 and x square will be 2x. 2 you can cancel now. So this will give you, I am not writing x right now, just writing the denominator a square plus x square under root. Now why I am not writing x? Because integration of 1 dx already gave us x. We got a x from here also. X into x will be x square. That can be written. And then the integration with respect to dx. First part is already done. Now we need to concentrate on the second part, which is x square by under root a square plus x square. So x square is here in the numerator. A square plus x square is in the denominator with the under root. Alright. Now I need this a square plus x square upstairs. So just add a square and subtract a square. When you add and subtract a square, what are you going to get? A square plus x square, you can separate it out. But remember there is an under root in the denominator. So a square plus x square by under root a square plus x square. This is under root and this is also under root. Then minus a square divided by under root a square plus x square. This we have separated these two terms and we will integrate them separately in a different way. Means in a different terms. So you know that x divided by under root x, it can be written as what? X to the power 1 by x to the power half. It goes upstairs. X and x 1 and minus half will give you half only. So x to the power half, that is under root x only. So you'll get under root x in this case. So you can just write under root a square plus x square and integral of this one. Now if you take a square outside, only 1 by under root a square plus x square will be in the denominator, that you already know. So this whole is like this. Okay. Now before we go ahead, this negative, let's multiply this in the separate terms which I showed you. I am making it negative and this is as positive. So we have dealt anything which is outside this x under root a square plus x square, which is coming after that. Okay. So we have this negative under root a square plus x square integration first, and then the second term is plus a square we have already taken out, and integration of 1 by under root a square plus x square or x square plus a square, you can write any of these. Now what do you see here? This under root a square plus x square integral is what we have started. This is I only. And what about this one, a square? Let's write the first term first, then I'll tell you about the last one. X under root a square plus x square is already there. Minus I will take on the left hand side. A square is outside. 1 by under root a square plus x square has a direct result. Now let me write it here. And I am writing it here just to keep this thing inside your mind. Like it is log modulus of x plus under root x square plus a square. So in place of integration 1 by under root a square plus x square, just write this log x plus under root x square plus a square. So let me write it here. Log modulus x plus under root x square plus a square or a square plus x square, and better is to keep it inside the bracket after log actually. Now this negative I goes on the left, I minus I, that is I plus I will become. So I plus I will become what? Twice I. Just write 2I here. On the right it will be x under root a square plus x square, and the second term is what? See, just try to coincide with that actual result. So a square log and bracket I am changing now, x plus under root a square plus x square as the second term. Now these two I am bringing downstairs on the right hand side. Now you see this is the result. How easy it was.